1.3.5. Rationalizing denominators. When an expression involving square root radicals is written, in simplest form, it will not contain a radical in the denominator. We can remove radicals from the denominators of fractions using a process called rationalizing the denominator. We know that multiplying by 1 does not change the value of an expression. We use this property of multiplication to change expressions that contain radicals in the denominator. To remove radicals from the denominators of fractions, multiply by the form of 1 that will eliminate the radical. For a denominator containing a single term, multiply by the radical in the denominator over itself. In other words, if the denominator is b square root of c, multiply by square root of c over square root of c. For a denominator containing the sum or difference of a rational and an irrational term, multiply the numerator and denominator by the conjugate of the denominator, which is found by changing the sign of the radical portion of the denominator. If the denominator is a plus b square root of c, then the conjugate is a minus b square root of c. How to? Given an expression with a single square root radical term in the denominator, rationalize the denominator. A. Multiply the numerator and denominator by the radical in the denominator. B. Simplify. Example 8. Rationalizing a denominator containing a single term. Write 2 square root of 3 over 3 square root of 10 in simplest form. Solution. The radical in the denominator is square root of 10. So multiply the fraction by square root of 10 over square root of 10. Then simplify. 2 square root of 3 over 3 square root of 10 dot square root of 10 over square root of 10 equals 2 square root of 30 over 30 equals square root of 30 over 15. Try it number 8. Write 12 square root of 3 over square root of 2 in simplest form. How to? Given an expression with a radical term and a constant in the denominator, rationalize the denominator. 1. Find the conjugate of the denominator. 2. Multiply the numerator and denominator by the conjugate. 3. Use the distributive property. 4. Simplify. Example 9. Rationalizing a denominator containing 2 terms. Write 4 over 1 plus square root of 5 in simplest form. Solution. Begin by finding the conjugate of the denominator by writing the denominator and changing the sign. So the conjugate of 1 plus square root of 5 is 1 minus square root of 5. Then multiply the fraction by 1 minus square root of 5 over 1 minus square root of 5. 4 over 1 plus square root of 5 dot 1 minus square root of 5 over 1 minus square root of 5. 4 minus 4 square root of 5 over negative 4. Use the distributive property. Square root of 5 minus 1. Simplify. Try it number 9. Write 7 over 2 plus square root of 3 in simplest form. 1.3.6. Using rational roots. Although square roots are the most common rational roots, we can also find cube roots, fourth roots, fifth roots, and more. Just as the square root function is the inverse of the squaring function, these roots are the inverse of their respective power functions. These functions can be useful when we need to determine the number that, when raised to a certain power, gives a certain number. A. Understanding nth roots. Suppose we know that a cubed equals 8. We want to find what number raised to the third power is equal to 8. Since 2 to the power of 3 equals 8, we say that 2 is the cube root of 8. The nth root of a is a number that, when raised to the nth power, gives a. For example, negative 3 is the fifth root of negative 243 because, open parenthesis, negative 3, closed parenthesis, to the fifth power, equals negative 243. If a is a real number with at least one nth root, then the principal nth root of a is the number with the same sign as a that, when raised to the nth power, equals a. The principal nth root of a is written as the nth root of a, where n is a positive integer greater than or equal to 2. In the radical expression is called the index of the radical. b. Principal nth root. If a is a real number with at least one nth root, then the principal nth root of a, written as nth root of a, is the number with the same sign as a that, when raised to the nth power, equals a. The index of the radical is n. Example 10. Simplifying nth roots. Simplify each of the following. a. Fifth root of -32. b. Fourth root of 4, fourth root 1024. c. Negative cube root of 8x to the power of 6 over 125. d. 8, fourth root of 3, minus fourth root of 48. Solution. a. Fifth root of -32 equals -2 because, open parenthesis, -2, closed parenthesis, all to the fifth power, equals -32. b. First, express the product as a single radical expression. Fourth root of 4096 equals 8, because 8 to the power of 4 equals 4096. c. Negative cube root of 8x to the power of 6 over cube root of 125 equals negative cube root of 8x to the power of 6 over cube root of 125. Write as quotient of two radical expressions. Equals -2x squared over 5. Simplify. d. 8 fourth root of 3 minus 2 fourth root of 3. Simplify to get equal radicands. Equals 6 fourth root of 3. Add. Try at number 10. Simplify. a. Cube root of -216. b. 3, fourth root of 80 over fourth root of 5. c. 6, cube root of 9000 plus 7, cube root of 576. 1.3.7. Using rational exponents. Radical expressions can also be written without using the radical symbol. We can use rational, fractional, exponents. The index must be a positive integer. If the index n is even, then it cannot be negative. a to the power of 1 over n equals the nth root of a. We can also have rational exponents with numerators other than 1. In these cases, the exponent must be a fraction in lowest terms. We raise the base to a power and take an nth root. The numerator tells us the power and the denominator tells us the root. a to the power of m over n equals, open parenthesis, the nth root of a, closed parenthesis, to the power of m, equals, the nth root of a, to the power of m. All of the properties of exponents that we learned for integer exponents also hold for rational exponents. a. Rational exponents. Rational exponents are another way to express principal nth roots. The general form for converting between a radical expression with a radical symbol and one with a rational exponent is a to the power of m over n equals, open parenthesis, the nth root of a, closed parenthesis, to the power of m, equals, the nth root of a, to the power of m. How to? Given an expression with a rational exponent, write the expression as a radical. 1. Determine the power by looking at the numerator of the exponent. 2. Determine the root by looking at the denominator of the exponent. 3. Using the base as the radicand, raise the radicand to the power and use the root as the index. Example 11. Writing rational exponents as radicals. Write 343 to the power 2 over 3 as a radical. Simplify. Solution. The 2 tells us the power and the 3 tells us the root. 343 to the power 2, over, 3, equals, open parenthesis, cube root of 343, closed parenthesis, to the power of 2, equals, cube root of 343 to the power 2. We know that cube root of 343 equals 7, because 7 to the power of 3 equals 343. Because the cube root is easy to find, it is easiest to find the cube root before squaring for this problem. In general, it is easier to find the root first and then raise it to a power. 343 to the power 2, over, 3, equals, open parenthesis, cube root of 343, closed parenthesis, to the power 2, equals, 7 to the power 2, equals, 49. Try at number 11. Write 9 to the power of 5, over, 2 as a radical. Simplify. Example 12. Writing radicals as rational exponents. Write 4, over, the 7th root of a to the power of 2, using a rational exponent. Solution. The power is 2 and the root is 7, so the rational exponent will be 2, over, 7. We get 4, over, a, to the power of 2, over, 7. Using properties of exponents, we get 4, over, a, to the power of 2, over, 7, equals, 4a, to the power of, negative 2, over, 7. Try at number 12. Write x, square root of, open parenthesis, 5y, closed parenthesis, to the power of 9, using a rational exponent. Example 13. Simplifying rational exponents. Simplify. A. 5 times, open parenthesis, 2x to the power of 3, over, 4, closed parenthesis, multiplied by, open parenthesis, 3x to the power of 1, over, 5, closed parenthesis. B. Open parenthesis, 16, over, 9, closed parenthesis, to the power of, negative 1, over, 2. Solution. A. 5 times, open parenthesis, 2x to the power of 3, over, 4, closed parenthesis, multiplied by, open parenthesis, 3x to the power of 1, over, 5, closed parenthesis. Equals 30x to the power of 3, over, 4, multiplied by x to the power of 1, over, 5. Multiply the coefficients. Equals 30x to the power of 3, over, 4, plus 1, over, 5. Use properties of exponents. Equals 30x to the power of 19, over, 20. Simplify. B. Open parenthesis, 16, over, 9, closed parenthesis, to the power of, negative 1, over, 2. Equals, open parenthesis, 9, over, 16, closed parenthesis, to the power of 1, over, 2. Use definition of negative exponents. Square root of 9, over, 16. Rewrite as a radical. Equals square root of 9, over, square root of 16. Use the quotient rule. Equals 3, over, 4. Simplify. Try at number 13. Simplify, open parenthesis, 8x, closed parenthesis, 1, over, 3, multiplied by, open parenthesis, 14x to the power of 6, over, 5, closed parenthesis. 1.3.8, Media. Access these online resources for additional instruction and practice with radicals and rational exponents. Radicals. http://openstacks.org/l/intraradical closing parenthesis. Rational exponents. http://openstacks.org/l/rationexpon closing parenthesis. Simplify radicals. http://openstacks.org/l/simpradical closing parenthesis. Rationalize denominator. http://openstacks.org/l/rationdenom closing parenthesis.